So all of them, when you look at them, they indicate a quarter to. So the best answer here is Z. All right. Name two time formats used to display time on the clocks. Now, as I told you, there are two of them. You either call it analog, which is the same as 12-hour system, or you can call it digital, which is the same as 24-hour what? System. All right. But you have to remember, in analog, this is where we have AM and PM. Here, we have nothing like that. However, when it's past afternoon, the hour you add on what? 12. But the morning hours, they will remain the same until past afternoon. They remain the same until noon. Then after that, you start adding on 12, 12, 12, 12. You get the answer to be displayed in digital. All right, write down in words the time displayed on clock B. Let's go to clock B. When you look at clock B, it's digital already together, but I want to write it in words. I mean in words, not in numbers. Let me write it down here for you to see what they're trying to say. This one, write it in words, is supposed to be a quarter to, one p.m. Oh, you can say a quarter to 1. We didn't know whether it was morning or it was in digital form. Yeah, it's a quarter to 1, as in 1 p.m. Or you can say a quarter to 13 hours. All right, because from here we are expecting 13 hours. All right, write down the number of clocks that clearly indicate a time in the afternoon. Write down the number of clocks that clearly indicate a time in afternoon. Let's come here and you see clearly. So this is one of them, B. It's afternoon. Because if it was, because it's digital, in digital midnight, it would be 00:45. You see that? But now this one's clearly afternoon. Why? It's because it's in digital format. It was not supposed to be like this one. Also, it's another one, clearly afternoon. Together. For the analog, we cannot use because we don't know where it is or what it is. Are they put AM, PM, then would tell. But we are only looking at digital. So it's only B and E. Write down the number of clocks that clearly indicate a time in, clearly. Take note of this, clearly. So we don't want to guess. If you use analog, you'll be guessing. So we said they said write down the number of clocks. So how many are they? There are only 2. In brackets, we said B and E. All right, please, you may pause and refer to the annexure. All right, let's continue and we see what's happening. Convert 16 hours, 45 minutes to minutes. Convert 16 hours and 45 minutes to minutes. In other words, these are already hours. These are minutes. We don't need to change them. Why? Our main aim is to have minutes. So remember, these are 16 hours. We need them to become minutes, yet 1 hour has 60 minutes. Simply meaning, get the 16, multiply by 60, get the 16, multiply by 60. We are fighting to say that they become minutes. So 16 times 60, you get 960 minutes plus 45. So all in all, we have the total number of minutes as 1 1005 minutes. 1005 minutes. Hours, they became minutes. Minutes, they're minutes. You can't change minutes to minutes. So you add everything together. We are continuing. Let's see that we go through this. All right. In paper 2, we shall be expecting measurements. Actually, you're looking at measurements and conversions. All right. And assembling of objects like we see here. Illustrated below are steps and some instructions to assemble a deck chair. To assemble the deck chair, the wooden pieces are joined together using fasteners, brackets, screws and bolts, washers and nuts. These are 32. Okay, there are 32 pieces in the packet of fasteners. Each bolt is secured by a nut and a washer. So anyway, it's fine. We should not overthink about it, but you understand. One bolt. The bolt is that nail that. So one bolt, it will have a washer. That small, there's a small disc-like material. Then with at the end, you put the nut together. So one bolt, this is a full set now. One bolt should have one washer and a nut. All right, for screws, you know the screws, you just screw and it fastens the wood. Go straight forward. All right, here we go. They are saying part A, it says, so the step 1, it says attach the seat using bolts, which is B, nuts E, and washer D to the front, so to the 2 front legs. Attach the long, which is A. Then we go to step number 2, which says attach the arms to the 2 front legs using the bolt C, E, and D. So here we go. We have attach the back of the seat and the arms using the screws, which is A. Together. Then step number 4, it says short brush. Okay. Here we go. Use C. Determine the number of type C bolts used to assemble the deck chair. We are looking at C. The number of bolts. Determine the number of bolts. Okay, how are we going to determine them? Remember, they told us there are 32 pieces in the packet for fasteners, and each, remember they said these pieces of a chair are joined together and using fasteners, of which fasteners include screws, bolts, washers, and nuts. And they are telling us that in only one packet we have 32 pieces. So let's come down here. When we look at this, when we look at this bolt C, they are missing. Numbers are missing here. So in other words, we need to know when I add my 8 screws plus my 6 bolts plus my type C bolts, which are not there, I will leave it as C, plus my D, which is 8 washers, plus E, which are 8 nuts. I should get the answer as 32. Where am I getting 32 from? From the scenario. A pack consists of 32 pieces. All right, when we add this very well, we shall end up saying that the answer that we have is 14 plus 8 is 22. 22 plus 8, you get 30, which is this means this simply means we have got 30 bolts plus C should give us what? Should give us 32. All right. So having done that, but when you add 30 plus C, what you get 32. So meaning our C is supposed to be 2. Our Our C is supposed to be 32. All right, state the number of nuts left over after step 1 is complete. Step 1, let me see. Step 1, what does it need? Step number 1 needs attach the set using bolt B, bolt B, nut E, and washer D to the 2 legs. So here we are. Let me see. And the A. But they're saying here, the question asks us, state the number of nuts left after step 1. Step 1, how many nuts does it need? You understand? We have the type E nuts, but how many of them? We shall have, let me see here, we have E again. We shall have 6 nuts. 6 nuts, because here we are. We have, let me see. Attach the stitches. They never told us how many nuts are inside here. But anyway, we shall take it to be, here you take E, 1 E. Also this other side you take E. So of the 8, you've taken off 2, because of these 8 nuts, you've taken off 2. So how many do you remain with? 6. 6 what? Nuts. Name the last piece required to complete the assembly of the chair. It was already named here. The last piece to it's this A. This part here. The short brass. So short brass. All right. 1.1.3. We have a map here that we need to look at and analyze. All right. They're telling identify the type of scale used. The scale is this one, which is here. Together. This one, whoever said a bar graph, a bar scale, sorry. Whoever says a bar scale, my friend, you're right. No any other. Guys, please refrain from guessing. Find someone saying a map scale because it's on a map. No, it's called a bar scale. Also, someone who says a line scale to be fine, but the right answer is supposed to be a bar scale. Name the province that lies east of Northwest. Remember, the map, what is it about? Or what is it for? It's for the Northwest. Yes, so definitely, Northwest cannot be east of Northwest. You understand? So they are saying, name the province that lies east of Northwest. East of Northwest. So first and foremost, look for a compass. If it has no compass, we take it by the compasses here. Simply meaning, it's like this now. The compass. This is the compass now. So we have north, south. This side becomes what? East, and this is what? West. So we come here. So we are supposed to look on this side here. East of north, west. So here I say Gauteng. It's Gauteng, but then this is east. What about north? Because if this is northwest, and we are looking for that lies. They said the province that lies east of Northwest province. East. So we shall say it's what? Gauteng. It's directly there. It's Gauteng. Gauteng lies east of Northwest. All right. Identify the national road that passes through Vryburg. First and foremost, identify the place. This is it. This is Vryburg. So we look for national roads. We have N14. It comes here, it continues as N14. Here we have N17. N17. N17, which is this, N14. It's around what? Vryburg. All right, those are the steps that we see. So they pass through. So they said, identify the national roads that pass through Vryburg. So we say N14 and N17, as we saw it on the map. All right, I'll write down the number of destination towns / cities shown on the map. There's a number of destination towns / cities shown on the map. Now, if you don't know that, most questions they have a key. Together. So they're saying write down the number. They didn't say mention, but they said write down the number of towns / cities. So what we're going to do, whatever word we find in this box like this, you just know it's a destination, town, or city. So here I have my friend 1, the other one's called 2. We have 3. Come down here, count that 4. We have 5, 6. We have 7. All right, someone might think of Pretoria. No, yes, it's there, we see it, but it's not in that box. Together. Another thing, someone might think of the N4s and the N. No, these are roads. They are not destination what? Towns. So we have 7 destination towns / cities. 7 destination towns or cities. That's it. Okay, here we go. Unfortunately or fortunately, we are not using any ruler. But if they say measure in millimeters, my friend, here, this is when you pick your ruler. Pick your ruler. When you pick your ruler, please you measure the distance as they have told you. Now, in brackets, I've said as the crow flies. So in simple terms here, they don't want you to use the string or the thread. Here, use a ruler and it will be a straight what? A straight line from one point to another. Now here they're saying as the crow flies from Blue Mouth to Leschenbach. Together. So you come here, identify the towns. We are here. Together. Then we are going to Leschenbach, which is this one here. The place is here. Ne? So put your ruler here up to here. Measure the distance that you get. Measure the distance that you get. Measure the distance that you get. So now what you're going to do, hello? What you do now, it's I'm going to just show you here something small. All right, you get your ruler. Get your ruler, then you measure from this distance here in a ruler. Please, with a ruler, sorry. You measure it from this place to this place. So let's imagine you have approximately, they said measure in millimeters. So you write it, approximately you have 12 millimeters. Yeah? So you come here down. No, this is too much. It's probably let's say you have 50. If you've got here 50 millimeters, you come down here and you measure it just right, and you say 50 millimeters. You use your ruler there, please. All right. Let's look at question number 2. Question number 2. Question number 2 talks of the annexure. Get it, please. What we see, it's what they want us to look at. So we are looking at question number 2.1, annexure A, which is 2.1. All right, it talks of a seating plan, I believe, and as you show it, as you see it, annexure A shows a restaurant seating plan for customers. Use the information on annexure A to answer the following questions. Give one possible reason why this restaurant has so many windows. One possible reason. This is simple. Number 1, to have fresh air. You understand? We need fresh air, air circulation, air flow. Number 2, to have enough what? Enough natural light. You understand? And if you have enough natural light, guess what happens? You don't need to switch on the lights. In the end, you cut on electricity. All right. Someone might have other reasons, like for easy fire what? Fire for example, in case of fire incidences, it's easy for customers to exit instead of them using one small exit. Others can jump over the windows and an easy way of escaping. All right, calculate the maximum number of chairs available for customers. Let's go to our next chair. The next chair is here, and numbers available for customers. Please take note. How many tables have 4? We have 1. We have 1, 2, 3, 4, 5, 6, 7. So this, remember, we're looking for the maximum number of chairs. So only these ones that I've ticked now, they are 7 tables, but each has 4 chairs. So those are 28 chairs. Keep them aside, please. Let's continue. How many tables have 1, 1? So we have 1, 2, 3, 4, 5, 6. So these are 6 what? Plus 6. We are going to add on. How many tables have 2? 2. It's only 1. So plus 2. Plus, how many tables have 3? We have 1, 2, 3, 4, 5. So it's 5 tables with 3 chairs. How many chairs are they altogether? 15. So what? 15 chairs. Plus, what's missing here? What have you ticked so far? We talked of chairs. We cannot count couch. All right? We're only looking at chairs. So here, the table number 18 has how many chairs? It has 6. Together. So table number 18 is the last one. All right? Someone might have seen the number of tables, 21. You get 21 and say, there are 21 chairs. No. We are counting chairs that are available, maximum number of chairs. So we've seen it's 28. 28 plus 6. I'm saying 28 plus 6 plus 2. Six plus 2 plus 15 plus 16 plus 6, sorry. Plus 2 plus 15 plus 2 plus 6. No, there's none of that. It's just like this. So 28 plus 2, 30. 36 plus, say, because I say 20, then here only it's 36. 36 plus 15 plus 6, you get 57. So we have 57 seats available for customers. 57 chairs, by the way. Determine the number of seats directly facing the wall on the south side. Let's go back to our next chart. So if you hear south side, so first and foremost, look for the campus. Together, the campus is not there, but they have given you here the main entrance doors are on the south side of the building. So definitely you have to look for the main entrance. So if the main entrance is here, so you're looking for chairs that are facing the south. Here we shall count them critically, or let's go and take note of the question. They are saying, name the number of seats that directly face the wall, the south side, directly face. Here we shall have, I think, 2 answers. Directly, so we have 1, 2, 3, 4, 5, 6. Yes, 6 what? Chairs. 6 would be okay. 6 seats. Or you say 6 plus. I'm going to show you something small here. This is facing the south hall. This is facing. Come to this one here. Come to this one here. Another one. Look at this one. What about this one? You see that? So we have 1, 2, 3, 4, 5, 6, 7. They are all facing the south. The south directly. Not because these ones can, but this is diagonal. We can't count these, but these ones are directly facing. So we can say 1, 2, 1, 2, 3, 4, 5, 6, 7. So I believe also that one who says 13 chairs, it's to be fine because we are adding all those 7. All right, let's give one reason why the restaurant has couches at the entrance. Definitely now the couches will be used by those ones who are waiting for takeaways, I believe. You see that? Not for customers who are waiting for their orders to stand in the queue. You know, it confuses. For example, if you go to KFC and you find people waiting to collect, they will be also lining, as well as those ones waiting to order. So it confuses a little bit. But if someone is waiting for an order, let them have a seat. Then you know what? I'm left with these ones to serve. So the couch are for those ones who are waiting to take their orders. Give one reason why a restaurant has couches. Give a reason why a restaurant has couches. So here we go, 2.1.5. A person at the table 18 leaves her seat and walks towards her friend at table 4. She uses arrows. She uses the arrow path shown on the seating plan. Use the compass direction to describe. Use the compass direction to describe the path from table 18 to table 4. Use the now. When you hear compass direction, what comes in your head? You need to mention north. You need to mention east. You need to mention west. You need to mention south. At the end, you're looking for news. Are together? So let's go there and we see table 18 is heading to table 18 is heading to table 4. Table 18 is heading to table 4. Let's go and check on their next year. And next year, and next year. Let's look at the annexure. All right, the person is in table 18 here. But okay, the person is going to use, they said use the arrow direction. At the end, they're also using the compass. So the compass, remember, this is north. So this is what? South. Why am I saying that? Because they told me the main entrance is found at the south of the building. So the person, table 18, they will move in the southern direction because they need to move like this. They're saying describe. They move southern direction. You move in the southern direction, or you move south towards table 7, pass table 7, then turn east. Turn east. Turn east. Having if you turn east, the third table on your left, that will be the person, because this is table 4. Person is coming from table 18. So south and east. Right? But if at all they are not said, if at all they have not said use the compass direction, this would be the person stands up, he moves towards table 7, which is he moves towards table 7 here, which direction is that? We can't, it's straightforward. Because if a person was seated here, he definitely has to leave the table, come onto this line, then he moves down. As he's moving down now, this is his right and this is his left. For you, this is your left and this is your right. But for him, his left would be here, his right would. So he will come here. So he will turn left after the after table 7. Then the person will be on the right-hand side after turning. All right. Let's continue. We look at question number. NOM claims that there are less than 21 tables for customers in this restaurant. State a reason why, whether her claim is valid. All right, let's go and we say annexure. Let's see if they are less than 21. Indeed, they are less than. Let me see. I'm going to count them. So we have 1, 2, 3, 4, 5, 6. Yes, these are 6 tables. 7, 8, 9, 10. Yes, 10 tables. 11, 12. Yeah, 13 is missing. 13 is missing. 14, 15, 16. 16. 17 is there. 18 is there. 19, 20, 21. Yes, there are 20. 13 is missing. There's no 13. Together? So we say there are 20 tables because the 13th table is not there. The 13th table, or table 13, is missing. Table 13 is missing. State the reason whether her claim is valid. It's valid. State with a reason why. State whether it has a statement is valid. Yes, there are 20 tables. The 13th table is what? Missing. It's not there. All right, let's look at the next chart B. Look at the next chart B. Next chart B, probably when I look at it here, I see a tree diagram. A tree diagram. Why do I say tree diagram? This is probability. A tree diagram because I see options. One protein, chicken. You take one of the, all of these are proteins, but you take only one. Then one side order, vegetables or salads. That's you pick one. Dessert, it's either ice cream or pudding. You understand? So that's why I just look at it and I see that it is what? This is probability. And they're asking which type of diagram is illustrated on the next chart B. Let's go to the next chart B and we see. And next chart B, here we go. All right, this is the next chart B, and as I guessed, it's probability. The kind of diagram that we see here, it's called a tree diagram. This is a tree diagram. These are the branches. These lines that you see, those are the branches. Together? By the way, we have no leaves and we have no stems, but these are the branches. We don't have roots. I think the roots would be these numbers that we see here. Anyway, look at this. As you see the table itself, as you see the you see the diagram, the tree diagram. This represents the first chance, the second chance. Together, this is the second first chance. Sorry, it's this one here because here we're supposed to also have a tree, as in it has to be coming. So this one is the first leg. This is the first leg. So this is the first leg whereby they had to come together. So here they need to come together like that. So that's how it is. So in case one is missing, for example, this one here, you will have to work backwards. For example, this, let me see, this is 2.2, 2.2a. They are missing. Anyway, we see that this combination was got from here. They began with a certain letter, which is F. So here it's supposed to have F. F, V, I. F, V, I. Let's come here. F, V, M. F, V, M. So F is supposed to be here. Let's guess. Someone give us the answer here. The answer here is supposed to be, now look at all these combinations under this. They all start with C. Definitely your answer is supposed to start with C, which is this one here. But it's at the last place here. So it's C, goes with S, and it ends with M. So C, S, M. That's supposed to be the answer. This is the tree diagram that we are looking at. That's how we get the combinations. Last example or last solution that I'm giving. Let me see, we have, for example, how did they get this? They took the B, wonderful. They took the V, wonderful. And they ended with M. So the branch went like that. Then it collapsed like that. Are we there? That's how we answer. Please never leave such a question unanswered. All right. We consider them to be free marks. We continue the other question. You see what other question are they saying? We've already completed this. They're saying name the type of diagram illustrated in annexure B. I've already told you it's called the tree. The tree is called the tree diagram. Write down the missing outcomes. We've already seen them from the annexure, which were A is CSM, A, CSM, and the B was F, fish. Say the number of combinations with beef as proteins. These ones are 4. There are 4 combinations. Let's go back to the next one. You see beef, which is B. It has split here, and look at where do you see B only? So you have 1, 2, 3, 4. So these are the 4. These are the 4 combinations that we have. The other question has to be, or it was, determine as a percentage the probability of randomly selecting a meal with pudding as a dessert. Now, what we're going to do, this is the sample. So probability will always equal to sample over the population. Sample over the population. Now, what's the population? The total outcome, the chances. Together? Then a sample, part of the population. Many of you have gone to supermarkets and you've seen that they're giving you, they will tell you that these are samples, simply meaning it's not a full pack, it's not a full package. They give you something small. So a sample is part of the population. All right, let's go there and we see. The sample you're looking for, it's the M. Together? But out of what? How many outcomes do we have? Here we have 4 of them. Here we have 4 outcomes. Here we have 4. Also here we have 4 out. I'm counting these outcomes here. Are they? Then having counted these outcomes, so all in all they are 12. So population, my population is 12. Of these 12 chances, how many combinations have M? How many combinations have M? I'll start with this one. This one has M1. This one has M2. This has M3. This has M4. This has M5. This has M6. So out of the 12, we have 6 chances that someone of picking someone who has taken OD. So we shall say it's 6 out of 12. They say determine as a percentage. So what do? We multiply by 100. But I'm here seeing 6 over 12 times 100. Your answer, it will become 50%. Why did I multiply by 100? They asked me to determine probability as a percentage. And I went ahead, I used the probability method, which is sample over population. But because they need a percentage, I multiply by 100. Out of my 12 chances, I have 6, which I'm sure of. Over 12 that are all the ones. And I multiply by 100, I end up having 50%. 2.3. Below is a simple route map of Los Angeles Marathon, LM, in the United States of America. LM, it's 26,2 miles. All right. By the way, the moment I heard of America, guess what came in my, remember we have two systems of measurements. Ne? We have the metric and we have what we call the imperial. The metric, it's what you use in South Africa, kilometer, meter. We go to centimeter and millimeters. Whereas imperial, we'll start looking at miles. After miles, we look at yards. After yards, we look at what we call feet. And we shall look at inches. This is imperial. Together, let's keep that in our heads. For metric, they'll always ask you to provide the values. But for imperial, they will always give you the conversion factor. Anyway, keep this in your head, 26,2 miles. Okay, here we go. They say explain the meaning of the route map. This is straightforward as you look at it. The route map only shows, or it shows the way people who are running will follow. You understand? Route. Which route are you going to take? Together? Remember, this is a marathon whereby people run in big numbers over over long distance. Together. Marathon, we also have what we call the cross country. I think the cross country is in the countryside, right? Whereas a marathon, even marathons, I also can. No, cross country is a longer one. Eh? Anyway, map not on scale, simply meaning their measurements are not perfect that much. All right. Describe what's meant by the map not on scale. Together? In simple terms, it's not actual. I understand? The measurements are not actual. It's not on scale. Runners in El Marathon have passed the underneath a bridge at a certain point during the marathon. Explain how this is indicated on the map route with no route line. What do I mean? Take note here. There's nothing there. Even here, so simply means they are passing under the bridge. Even here. You understand? Here, they pass under. That's why the route is not indicated. As you here, you see it's clear. But here, it's under. That's how it's indicated. Come here, it's under. Come here, it's under. Also here, it's under. That's how we know that this guy is passed under the. Then this one here would be like a subway. Or a subway, what do you call it? A tunnel. Or lanes. Anyway, let's go and see. Write down the number of times that runners who completed the marathon will pass underneath a bridge. So that I was looking at. I said, how many times? So let's count this as 1. We come to this, we call it 2. Come to this one here, 3. And this one, we have it as 4. Any other part where the marathoners not, it's not clear. Probably 5 is something here because this is a start. This is an arrow. There's nothing there. So we go on and you see 5. There's no any other place. All right, this is 5. 5 times. Write down the general direction in which runners will face when they start in Flower Street. Now, when we look at general direction, please take note. General direction, you are not describing any route. General direction, what has to come in your head, it's the compass direction. Some people call it compass. Together? The compass direction, the north, east, west, and the south. That's what we're looking at. So let's go there and we see they said, write down the general direction in which runners will face when they start running. Now, before you give the general direction, you have to look for the compass. Now, here the compass points at this side. Look at the end. So simply meaning up there. So this side is what? East. This side is west. South. On top here, it's what? North. Together. So where are they facing? You come here. Try to draw the compass and look at where they are facing. South, west. South, west. Avoid writing shortcuts, but you should write it in full. All right. Question number 3. Here we go. These are measurements. Look at measurements. We look at area, perimeter, volume, surface area. Okay. That's wasting a lot of time. Let's look at this. Let's analyze actually the box and we see. Every learner in a technology class is expected to have pre-stick and pretty glue sticks. The pretty is packed in a rectangular box, sleeve, and the pretty is in a cylindrical container. So here we go. Rectangular shape. Here we are looking at it. So we have 2 shapes here. 1, rectangular. 2, cylindrical. All right. The dimensions of the rectangular face of the pretty sleeve and the cylindrical pretty containers are given below. All right, pre-stick and pretty glue stick together. This is called a glue stick. The people call it pretty. All right, and we go on. Okay. We have definitely for a rectangle, you expect to have length, which is L, width, which is W. Most cases, we also need height. If it's a 3D together. Then a cylindrical, we only need the diameter and the height. This is already 3D. There's nothing much that you need to do. All right, there we go. It's calculate the perimeter of the front of the pre-stick. Number one, pre-stick sleeve. So it's this one here. So the perimeter. So simply mean, what's perimeter? Perimeter is the total distance around a given shape. And they've given the formula. Please, once they've given the formula and you indeed know that's the right formula, just continue, substitute in it. So we shall start with a 2 times, open brackets, length, 239, plus width, which is what? 89. Make sure that all of them are in the same units. So they are all in the same units. I need to go ahead. So having done that, your final answer becomes, don't forget the units, 656 millimeters. Millimeters. Okay, here we go. They tell us to calculate in centimeters. Take note of that. Calculate in centimeters the height of the opening / the closing part of the pretty container. We come and we see it here and we see, look at that. Look at that. This has parts together. Oh, the cap, yeah. The cover. The height of the opening / the closing part of. So it's the bottom part, this one, which is dark here. So we need to know. Okay, they're saying calculating the height. Oh, okay, it's so simple. So what is going to be? Look at this. So simply meaning, when from here up to there, let me call it O. No, Q. Let me call it Q. Because I don't know this, I'm calling it Q because I don't know it. From there up to there, it's Q. So when I add my Q plus my 7 plus my 2,5 centimeters, I should end up having 114 millimeters. But look at this. These are centimeters. Also, this has to be in centimeters. But these are millimeters. What you're going to do, you're going to change the millimeters to centimeters. So I need to change my 114 millimeters. I need to change it to centimeters. How do you change millimeters to centimeters? I will need to divide by 10. I'll need to divide by 10. So here I end up having 11,4 centimeters. I've changed this, but it's not the end. So we are saying when I get my unknown number plus my 7 plus my 2,5, they should give me 11,14. All right. So here when I add this, I end up having my Q plus 9,5 equals to 11,4. But I'm looking for the Q. Which number do I add to 9,5? I get 11,4. So my Q now become 11,4 minus 9,5. 11,4 minus 9,5. I end up having my answer as 1,9. We said we shall take the total height the total height has to change to centimeters because they need my answer to be in centimeters. The total height, which is 114, we shall divide it by 10, get 1,4. So when we add these other areas, they should give us this. When I add my unknown, add plus 7, plus the 2,5, I should get 11,4. Simply meaning this has to be 7 plus 2,5 plus the unknown. When I add these two, I end up having 9, I end up having 9,5. So I will say 11,4 minus 9,5 equals to Q. Equals to, please take note of that, centimeters. The actual height of the glue in PRET container is 8,5 centimeters, and the volume of the glue rounded to 30 decimal place is this much centimeters cubed. Show by calculation that the volume of the glue was calculated if the diameter of the glue is 28 millimeters. The actual height of the glue so the glue inside the container is 8,5 centimeters, and the volume of the glue rounded to 3 decimal places, it's this much. So we need to we need to show that the diameter is this much. But look at the formula they used. You understand? But in your head, because you're determining the diameter, you know very well that diameter is got from you getting the radius and multiplying it by 2. Together. So you're going to use this formula, you're going to use these values here. And the volume and the height of the glue and the formula to get the radius together. So this will be my volume, yes, which is 52,346 equals to 3,142. Do we know the radius? No, but allow me leave it as r squared times, do you know the height? They told us it's 8,5. So we multiply the normal numbers and leave the r squared alone, which is 3,142 times 8,5. You get 26,707. Please, I will leave the number the way it is. I won't round off. Let me do it from here. This is part B. Volume equals to pi r squared h. Remember, they've given us the volume already. The volume was given to us as 52,346. So 52,346 equals, when you multiply the pi and this number here with the height, and having 26,70 times the r squared, because the r is missing. So what do? I need to divide through by, there's a comma here. I need to divide through by 26,77 on both sides. On both sides, so it becomes 5,346 divided by 20. So when I do that, this will die with that. So I remain with my r squared equals to 1,96. So what do? I need to look for the radius, which become the square root of this, square root of my answer. Yes, indeed, I remained with r equals to 1,14. But remember, we are not interested in r, but r will help us get the diameter What do you do? Multiply by 2 and times 2. So I end up having, these are centimeters. The proving is in millimeters. I need to multiply by 10. Indeed, I've done it. So this was the answer. This is part A. Part A. Part A. Looking for the diameter. What I would advise you to do, let's look at this. Volume of a cylinder will always be pi r squared. So this we can put it in the triangle like this. Volume equals to pi r squared h. So if I'm looking for, definitely pi is a constant number, there's nothing much there. So if I'm looking for h, height, if I'm looking for height, it will be height, yes. What am I remaining with? I'm remaining with volume divided by pi r squared. So simply meaning if I'm looking for height only, height, what am I? I'm remaining with this. So which will be radius squared equals to volume pi r h. But this is squared. So what do we do? Whenever it's squared, we need to apply square root. So we need to apply the square roots on both sides. That's how we do it. This is how you remember these formulas here. If you ask for radius, square root of volume divided by pi r square pi h. Whereas if you're looking for height, it's volume divided by pi r squared. So definitely if you're looking for volume itself, it's the bottom part, all of it. That's how we remember those. That's how we remember the formula. Okay, we look at the second question. It says, determine and round it to the nearest gram mass of the glue in the pretty container if the density of glue is 0. So density here, they have told us that density, the formula is here, density equals to mass divided by volume. So we determine the round up to the nearest gram, the mass of. So we're determining mass. Mass simply meaning it will be density times what? Times volume, which will be density, they have already told us is 0.82 times the volume of the glue, which is already what? So the mass, they said it's 442.92 grams, but they said round off to the nearest. Take note of this. So here it's 93 what? Grams. Why did I multiply? Because this one here, in actual sense, it's density equals to mass over volume. You are interested in mass. What happens? M will remain and the D will multiply with the V.